When we talk about RAG system, retrieval augmented generation, I'm usually talking about a system that allows you to take text and pass in as a prompt, and then because it's a RAG system, we have attached external documents. All of that is put together, and then we put or send that all through a large language model so we can get results, because now the RAG system is able to go and find pieces of information, in this case documents related to the question, which is a prompt, and put it all together, pass through large language model, and get the result. And as you see, all of that is textual, meaning the results, the inputs and results are text based, or in the world of data, things don't come as textual only. And so when we have a multimodal RAG, the system now not only handles only textual information, but also can handle other types of data, such as videos, images, and so forth. And that is what we're going to talk about in this mini course. I'm going to show you how to look into these RAG systems, but not just into textual in the singular side of things, textual side of things, but also in the different modalities. In this case, we have different kinds of data, as I said, images, videos, and so forth. So you can understand how to put it all together so you have a more powerful and richer RAG system. So let's go ahead and get started. On the other hand, when we talk about multimodal RAG, what we're talking about is we have a multi or more than one form of embeddings. What that means is as follows. Let's start by using a motivation here. So imagine a user has a query, is passing in a query of text, written text, and also passing in an image as a query. So what happens now is that we'll have two things that would happen. So we have the text embedding that will happen, and of course the image embedding. So now these two will be embedded differently, but then we're going to put them together. So this is what we call the multimodal fusion. So we take that query, which has text and image. Separately, they are created, or those embeddings are created separately for text and image. But then we fuse them together so that we have this query embedding, which is multimodal fusion. Okay? And that is indeed what is passing along for the retrieval of data. So in this case here, in this space, now we have this multimodal vector space, essentially. We have the image data, in this case, thumbnails, visuals, and so forth, and we have the textual information. From that, we have the combined retrieved data. So in this case, it will be text plus images, and that is what's passed along to indeed generate the response. So this is an overview, a very simplified overview of what multimodal is. The beauty of multimodal RAG is that it extends the standard RAG framework as we know it. It does that by retrieving and generating information across multiple data modalities. When we talk about multiple data modalities, we're talking about text, images, video, audio, etc. This is essential because if you think about many real-world tasks do involve more than just textual data. As an example, we could have, for instance, a video recommendation system may need, in this case, to consider text descriptions, thumbnails, which are images, and also video content. So now we're talking about audio or transcription. So it depends on all of this to be able to generate those recommendations. Okay. Another example would be, let's say, in healthcare. So we might have AI. So in this case, AI might need to retrieve patient records, which are in textual format, medical images, in this case, for example, x-rays and so forth, and lab reports. So this is structured data. All of that is needed to generate meaningful insights. You can see in all of these examples, we actually are talking about not just a textual side of things, right? Textual data. We're talking about a variety of different types. That's why we need this multimodal system. Now, when it comes to multimodal RAG, we have two options. So the first one is multimodal embeddings. So this is responsible for generating vectors, usually 1408 dimensional, so very large, from inputs that can include a mix of images, text, and video data. Now, these embeddings place both image and text data into the same semantic space. That's very important. All of this is put into the same semantic space, meaning they share the same dimensionality. Now, why is this important? Well, this is important because it allows for a more flexible use cases like searching for images using text queries or finding relevant videos using image queries and so forth. A good workflow would go as such. We would use the multimodal model to generate embeddings for both text and images, as we saw. And then, number 2, perform similarity search to retrieve relevant items, for example, images or text. And the third step would be to pass the retrieved images and text chunks to a multimodal language model to synthesize a complete answer. So that is essentially what we saw before in the diagram. Now, the other option is text embeddings. Now, this is one that we are mostly familiar with because that is what that's the basics of embeddings essentially. So in this option, what we're doing is the system leverages a multimodal language model to generate text summaries for visual inputs like images or video frames, etc. So these text summaries are then embedded and stored in the vector space, in this case in the vector store. So in this case, the steps would be, to use a multimodal large language model to generate the textual description or summaries of the images. And step 2 would be to embed the generated text and then perform similarity-based retrieval. And the third part is we would feed the retrieved text chunks into the language model to then generate a comprehensive response. So we've seen this, so I just want to show you the differences here of multimodal embeddings and text embeddings. So if you look at this image here, this depicts the multimodal embedding. So essentially we would have text that says a dog running, an image of a dog running, and similarly we could have a video of a dog running. And the beauty here is that all of these are actually transformed into embeddings. Different embeddings, different models are being used and so forth. But the beauty is that all of that is actually passed through, it's put into the same embedding space, what we call the unified embedding space. So this is what allows the comparison and the interaction across different data types. So all of these embeddings of the textual format of a dog running, of the image format of an image of a dog running, and a video of a dog running, all of those embeddings are put into this one large unified embedding space, which again allows for faster comparison and interaction across different data types because everything is in one place. Now, the question, of course, is why multimodal RAG? Why is that even part of our lingo? Why do we care? For many reasons, as we've seen, but I will reiterate here, is that when we use multimodal RAG system, is that we have a richer data sources, right? Because information in real world, as you know, comes in multiple forms. It's not just text, but it comes with text, images, videos, audio, etc. So limiting a system to only one type of data means we are overlooking a vast amount of information that could be useful. For example, image and video retrieval systems, they need the ability to interpret and also retrieve visual content in conjunction with textual data. Okay? And we also have a better context understanding because by pulling from, in this case, multiple data sources, multimodal RAG can generate more comprehensive answers or recommendations, right? And as an example, imagine in a e-commerce site, an AI system might retrieve product images, user reviews, in this case is text, and video reviews to generate a comprehensive product recommendation. Also, we have this complex query handling because multimodal queries often combine different forms of input. So a user might search for instance, AI in healthcare, while also uploading a relevant medical image. So multimodal RAG can integrate both text and image data to then provide more accurate and richer results. And we talked about is real-world scenarios. As you know, most real-world tasks do involve multimodal data, not just mono data, right? For instance, a movie recommendation system might use the title, description, which is text, thumbnails, image, and user ratings, which could be numerical data, for the recommendation. So a multimodal RAG system allows for a deeper and more nuanced understanding of the content, which leads, of course, to better predictions or answers. So now we're going to look at how search is integrated into a multimodal RAG system so that we can have a full overview. Okay. So first of all, let's look at this nice diagram here that I put together. I'm very proud of it. I hope this is helpful. So the idea is very simple, is that we have the user query. So it comes into text plus image. Okay, so user query, the system is going to receive input from the user in this case, which can be a combination of text and images. For instance, we can say, what is AI in healthcare? And then add, of course, a medical device image. Okay, so that is then passed along. Now, we talked about those two ways, two things that need to happen. One is the query embedding. So first, we are going to get the text part of the query to be processed through a text embedding model, such as GPT, BERT, etc. Doesn't matter at this point, right? And on the other hand, for the image side of things, we would use a model like CLIP, right? This is a model created by OpenAI that deals with generating embeddings for images. And so what these embeddings are then combined into what we call a multimodal embedding to represent the query in a single vector space, right? Both of those embeddings, the text embedding and the image embeddings, are now put together into this multimodal fusion, okay? Multimodal embedding. And so then what happens is that we can do similarity search. So in the text side of things, we do the text similarity search to get documents, articles, and so forth. And then in the image side of things, in the image embedding side of things, now it's used to perform similarity search across a database of images. In this case, we could have medical images, product photos, thumbnails, etc. And the next step is retrieve data. So relevant text information, in this case documents, articles, is retrieved based on the text similarity search done before. And then similarly, when it comes to that also, there is this image similarity search, which will retrieve image information. In this case, could be relevant charts, thumbnails, etc. We have the textual side and we have the image side, but all of this now we're going through the process because everything we have these embeddings, right, with this multimodal fusion of these two kinds of embeddings. So once we have this retrieved textual information and retrieved image information, that is all combined again into what we call multimodal fusion. So we're combining the text plus the image. And that indeed is what is taken through the large language model to get the final generated answer. So visually, that's what is happening here. We are showing how the multimodal search integrates into the RAG process. So we're retrieving data across different modalities, which means text and image, and then feeding it into a generative model to produce a comprehensive response. Now at this point, you already know why multimodal search is powerful, but I'll just go ahead and put in writing here and show you some diagrams so we really understand what's really happening here. So the first one is that we have this richer information sources. What that means is that, as you know, in the real world, information comes in various formats, text, images, videos, etc. So by searching across multiple modalities, the system can retrieve data that a single modality search would miss. We talked about that. As an example, if you are searching for a product with both text, for instance, black running shoes, and also an image, a photo of specific style, that of course leads to more accurate and tailored results compared to just searching with text. And we also have cross-modal retrieval. So here, one of the most powerful aspects of multimodal search is the ability to cross-reference modalities. This allows for retrieving non-text content using text queries and vice versa. For instance, a user can search for machine learning architecture and receive both diagrams, image-based in this case, and explanatory articles, text-based in this case, right? And also we can have an image of a landmark that can be used to retrieve text-based historical data or articles related to that landmark. So that's what we mean by cross-modal retrieval. And then we have this enhanced user experience, because as you see, when we have this multimodal search, it creates this more engaging and user-friendly experience, which allows users to interact with the system using their preferred input methods, right? Some people like textual method, some people like to add just images or both, and so forth. So we give users the capability of uploading an image, type in text, or provide an audio snippet to retrieve relevant content. Okay, and this flexibility makes the system much more versatile for a range of applications, from e-commerce, like finding products by photo or description, to even educational systems, like retrieving video tutorials alongside articles. And of course, we have this improved accuracy and personalization because we combine these different data types. Multimodal search provides more accurate and contextually relevant results. Okay. And we have, of course, we looked into real world use cases in the medical field, education, e-commerce. All of these can be used. Now, next, what I'm going to do, I'm going to show you each one of these items that we looked into here in a more graphical way. Now let's look at each one of these points into a bit more detail, at least visually. So the richer information sources. So if you look at this diagram, you can see that, again, we've seen this before. When a user comes in and passes text and or plus image, in this case, the process starts happening. So we have this text query that's passed along, as well as the image query. Okay, and all of that, as we saw before, all of that is put into this multimodal search engine. We have search text plus the image data. And then, of course, the results is that we have this text data, would be articles, and we have the image data, which is the visuals in this case, right? And then all of that is combined to get this rich, comprehensive results, because we have text plus images. So this is the richer information resources. We're not just focusing on one textual nor just image. We have this capability of having both textual and visual. So the next one is the cross-modal retrieval. Now, this is important, as we see, and I want to repeat myself here. Now, the beauty here is that in cross-modal retrieval, a text-only query can retrieve both text, in this case articles, and non-text images, making the search far more powerful. Even without providing an actual image, users can get image-based results. So the example here is as follows. The user goes in and says, explain AI in healthcare. Even though they're not passing an image, this is just textual, that text goes through the embedding process to get embeddings, and then goes through the search across multiple types. So in this realm here, we have text, images, videos, audio, and so forth. But this text embedding goes through, we are able to even retrieve, in this case, articles, which is all text-based, even also retrieving medical images, which in this case are visuals, even though we know that we just passed a textual query. And then, of course, we just get articles and related medical images for this example. So this is cross-modal retrieval. The beauty here, again, is that even without providing an image as a query, users can still get image-based results. Right, so we have this enhanced user experience here. So in this case here, we search with text or with image, doesn't matter. Text query, image query, the same thing happens. We go through this multimodal search engine where we can search across text, images, and so forth. And then in this case, we ended up with results text plus images, which gives us these comprehensive results based on user input. So it's beautiful because users get to choose which one they want to do, or both, or one or the other. Okay, there's this flexibility in how the users can interact with the system. Now we talked about improved accuracy and personalization. Now, this is a good one because now the system can, of course, personalize results by weighing the importance of text and image data based on users' preference or past behavior, which leads to more accurate recommendations. So you see here, the query goes in AI in healthcare, plus the image is passed. The same process happens. We have text embedding and image embedding go through this multimodal search engine. But the beauty here is that there's this personalization that happens. Start weighing what makes more sense or what needs to be elevated, be at the top than the other. So in this case, text could be 70%, image 30%. And so its personalized recommendation would be based on text plus images, which in this case leads to a more accurate recommendation. And we can look at the real world use cases, in this case, e-commerce product search. So a user comes in and read running shoes and passes in an image. So we have the text embedding, same thing, and image embedding. We go through this multimodal search, find products by text and images. And then we get the same thing. We get product information in a textual format and the product images, in this case, in the visuals format. Okay. And then the result is that we have the product listings, which will contain text plus images. These diagrams show how multimodal search enhances the system's ability to deliver more relevant, diverse, and also user-friendly results by leveraging multi types of data. So that's what I want you to get out of these presentations. So next, we're going to go ahead and do some hands-on and see how we can do this multimodal search. All right, let's go ahead and get started with this multimodal search. So the idea here is very simple, but before I even go there, let's look at the project here. Keep in mind, you will have access to this code, so don't worry too much about the code, right? So I just want you to see the concepts and try it out. So first of all, I have this images folder here, which we have a few images of foods, dishes, as you can see, and images of lion, and also tiger. So we're going to use these images because we want to do this model. And of course, I created a virtual environment, and I have the .env file, which later you will see. This is where you need to put your OpenAI API key. I have this multimodal star.py, and it's empty right now. So what we'll do here, we're going to start slow, which means we're going to start by building this whole concept from scratch. So the first thing we need to think about is that whenever we're creating a RAG system, we need, of course, a database. So not any kind of database, but this has to be vector databases because we want to add vectors into that database. Makes sense. And so what we'll do here is first we're going to do some installation, or rather pull in some dependencies. Okay, so I'm going to pull in ChromaDB, Pillow, OpenClipTorch for later, and Matplotlib for plotting and showing images. So let's go ahead and do that. Okay, so all is good. And before I move forward, let me explain something. So if we go to the Chroma website here, you will see that we now have, or Chroma has these embeddings, concepts, and this multimodal embeddings. So they have added that as well. What does that mean? Well, it says here, Chroma supports multimodal embeddings functions, which can be used to embed data from multiple modalities into a single embedding space, which is exactly what we want. So this is one of the reasons why I'm simply going to use Chroma in this example. Okay, so you can read more about it. They even have, Chroma has OpenClip embedding function built in, which supports both text and images. So this OpenClip is from OpenAI that does just that, right? Helps embedding these different texts and images into one modality, one single embedding space. And it's very simple. We can just pull that in from ChromaDB and say OpenClip embedding function. And you can see we can also create multimodal collections and do all this great stuff, which I'm going to show you right now. So I just want to show you that that's the reason why we're going to be using ChromaDB for this. Now you can use different databases, different vector databases out there, but we're going to use this for simplicity. Let's go ahead and do some importing here real quick. So I'm going to import Chroma. Looks like I'm not showing anything. Let's go ahead and get the correct. There we go. Okay, so now we have Chroma, and we're also getting this OpenClip embedding function as I was explaining. And also I'm getting this image loader because we're going to be loading some images, and it's going to take care of all that. And we also have this plot, this Matplotlib, so we're able to plot and see some of the images. What we'll do first is we're going to create a Chroma object, right, to persist data. So this is how we do it. I'm going to close this down. So we say chroma client, persist client, and pass the path. So I said data, and I want to call this chroma.db. So when we run this, it's going to create an actual database called chroma.db. Okay, so we also later, because we're going to use that, I'm going to go ahead and instantiate our image loader, which allows us to load image and do all sort of things. And most importantly, we're also going to instantiate the multimodal embedding function because we need that. Okay, so there we go. We just say embedding function and open clip embedding function. Okay, so once we have that, we can go ahead and create the collection. In this case, the vector space or the vector database. Okay, so there we go. I call this multimodal. So we say get or create collection. There are different functions you can use, but I like this. So that way, if there's one already, it's going to go ahead and get it. If there's none, call this, right, collection, then it's going to go ahead and get it, or create it, I should say. Okay, and importantly here, we're going to pass the embedding function because we want to make sure that this collection knows how to create those embeddings. That's why we created this embedding function, open clip embeddings, because it allows for text and images. Okay, that's why we're doing this, and we're passing that reference in there. And for data loader, we have the image loader, which we created here. So this is important because this embedding space here, it needs to load those images and do the embedding and all that stuff. So we need to pass this loader class instantiated there. All right, so next what we'll do is we're going to add those images to the collection like that. Now I'm going to say update, this is for later, but I put here add for the first time. Let's say add for the first time. And for next time, whenever you run this, we want to put update. So what we're doing here, we're adding, first we need to put IDs. So just put 2 items for testing purposes. So ID 0 and 1, and URIs, it's going to be where these images are. So I have this images folder here. We have a bunch of images. So I'm pulling in lion and tiger, and that's what I'm doing here. And for metadata, so I can actually pass metadata for each one of these items that I'm putting in this collection. So in this case, I can say the category, it's going to be animal for all of these items. Okay, so each one of these items is going to have the category animal. Okay, so let's go ahead and see if this works. I'm going to just run this real quick, and I'm going to return, in this case, print the count of this collection. So how many items we're adding in this collection. And what I like to do is I like to open this so we can see things happening, because it's always fulfilling, really. Okay, let's go ahead and run this. Okay, if all goes well, we can see a data is going to be created with database and everything, and we should see something. All right, very good. So we have some few things here, so just ignore all of this. But most importantly, we can see that we have number 2 at the bottom here. So that means indeed 2 things were added to our vector database. This is wonderful. And if you open here, you can see that we have a few things. Make this a little larger, and we have this Chroma SQLite. And one thing you can do, this is really fun. If you say Command Shift P to open the palette here, and you can open the open data or run this open data, it's going to go ahead and show this Chroma SQLite. If you have more than 2 SQLite databases, it's going to give you the option, but we only have one. If you click, you can see that now we can explore the SQLite database. It's just something to look at, and I always like doing that. Okay, so now we can see that indeed, if I go to, let's run this one, you can see that something is happening in our collection. We have this multimedia collection, which is the name we put together, and it has all of these things, this space, and all this metadata. And for the metadata, you can see we have indeed animals, tiger, and image. So we can see that we have those metadata that we passed along, category of animal, and so forth. And if we run this embeddings queue here, you'll be able to see that indeed we have the topic was created, and we have the actual embeddings. These are the actual embeddings, gibberish that you see here. Okay, so this is a vector space. We're able to create database, the vector database, and create those embeddings of textual as well as the image. Now that we know that everything is working, I'm going to comment this out, and I'm going to put here a print query results function that is a helper function to allow us to show things, right, coming from our database. So essentially what we're doing here is that we have query list, which is going to be a list, and query results as a dictionary, and returns a none. Okay, we're going to go ahead and look for items like IDs, distances, data, documents, metadata, URIs, all of that coming from our 2D list that we created here. Okay, so that is as comes in as in query results. Okay, and so that's what we're doing. And of course here we are printing the actual distance. The distance, remember how similar, semantically similar are the query and the results that we're getting, right? And the metadata, that's what we added to the database accordingly attached to the items that we saved. In this case, we only have 2 images and so forth. And of course the documents. So we're saying that's what we want to look at or see to print. And here I'm just printing the URI first of each image, if that's what we are getting, or one image depending. And then I'm going just to use plot. I'm going to plot those images so we can see. So what I can do now, because I'm going to run this again, I'm going to just change this to update. That way it just updates. All right. And so next what we'll do is I'm going to create a query text that we may need. Actually, we are going to need. So in this case, I'm going to pass as a list because we can pass more than one query inside here. So, and then I'm going to go ahead and query the vector database by passing this query. So all we do, we said collection. Remember, collection is what we created at the top here, right? So we have something. In fact, what I can do, I can comment this out right away. Let's go ahead and comment this out because we don't need that. Okay, so we have that collection and we're going to invoke the query. That's the beauty of using Chroma database. So the query allows us to pass the query texts. Let's see, it's plural because we can pass more than one. That's why we're passing a list, and the results that we want. How many pieces of information documents that once the search happens, I want to return. In this case, I'm going to say 3. Let's just say 2. We know that there's only 2 items there. And let's include, we can say we want to include certain pieces of information. We want to include documents, distances, metadata, data, and URIs. URIs because we know we have images as well that were included in the database, right? Not necessarily images, but you know that we have the image representation, the vector representation of those images. So we want to show those. Also, we can pass the filter here where category is animal and do all those things, but I'm going to remove that for now. All right, so now let's see what we can do. We can call the helper function and pass this information. So we have query text and query results, which will know, if you remember, how to deal with that and loop through and show us all the information that we need, and as well as plotting the documents that were found. Okay, let's go ahead and save and rerun this. And to avoid all of this gibberish here, let's go ahead at the top. I'm going to import warnings, and then let's go ahead and ignore all these warnings, suppress all of them. All right, let's go ahead and run again and see what will happen. So it takes a few seconds because it's doing a lot of work, doing the search and getting all that information. And just like that, you can see that indeed we're getting this plotted. Now, because of the way things are, what happens is that as I close, it's going to continue with the program. Okay, so you can see that we have here a tiger, and the distance, because we say tiger, is 1.429. Very good. And it gives us the data, which in this case is the URI to that image. Image is tiger.jpg. Very good. And we have distance. First, we want to say ID, distance, metadata is category, and the document. So if I close this, you can see this will continue, and then it gets another animal, which is animal lion. But you can see the difference, the distance here. So this is closer to tiger, which is the query, and this is not necessarily closer. So that's why it's 1.6, and this is 1.4. So there we go. We're getting the results. Right? So this multimodal search is working here. If I finish that, you can see that we have our program stops and we have the results there. Also add, for instance, more items. If you look here, I add more images. You can also add all of other images yourself, right? So I have these images of foods, dishes. And let's go ahead and see if we can add those as well. right about here. So here I am doing a lot of things manual here because we just have a very simple example. So we need to create, say, update. I'm going to just say add because this is the first time. Let's just say update. Okay, so we are saying IDs, we're passing a 23, all of those IDs, we can change that. And URIs, we're saying where can we find those images? We know we passed them inside of here. And we did all that. And of course, metadata, we're saying for each item ID, we're passing the ID, we're adding category, item name, and so forth. We can add anything we want here. That's the beauty of using these vector databases. Okay, and do the same with the other item as well. So now if I say food with carrots, something like this, let's see what will happen. Let's go ahead and run. Remember, this is it's going to hopefully update everything in our database. Let's run this. Okay, so it went ahead and did everything. You can see it says update, non-existent embedding. So it's showing that, okay, so it's not quite working, I think, because instead of updating, I actually need to add, because this is the first time that I'm running this. Okay, let's just say add. Makes sense. Let's go ahead and run. So now it's going to run and add the new information into database as vectors. Let's go ahead and run. Aha, there we go. So this now works. And you can see because the query is food with carrots. So you can see that it went ahead and gives me the distance 1.49, category food, and you can see it has some carrots there. So if I close this, it's going to show this one too. It's got some carrots there, and that's very good. Very good. So it's really, really helpful and it's accurate. You can see both of them 1.49 and this 1.5. So this seems to be the closest in meaning to our query, which is exactly why it has 1.49. And this is 1.5, which is still closer. And the beauty here is that we get all that information from searching this multimodal environment, from doing this multimodal search. So we're able here to pass in queries through text, where we have the images that were transformed into vectors, as well as the queries, the information that we write, are also transformed to be able to do the search and return, in this case, the actual images as you saw. And there you have it. This is a very simple multimodal search that we were able to do. So what I want you to do is to take this to the next level, maybe adding more images and add different items here instead of that. And maybe we can run, and because we know the query, we can put more than one. I can say food with carrots and a tiger, say foods with carrots. And instead of adding, let's just say update for now, even though it doesn't matter really. Let's say update so that we don't accidentally add things that are already added. Okay, let's go ahead and run this real quick. We could have commented that out as well. Okay, so there we go. So now we got the results. Okay, tofu, very good. That's looking good. And voila, you can see it went ahead and showed also a lion because it's part of the query, and it's showing, of course, everything else. But the idea is that it was able to rank everything. So food with carrots, let's see, and of course it got lion as well, because this, you can see, is for 1.44. That's very good. And food with carrots, it got that. Okay, so we're able to pass different queries as a list, and just like that, we're able to put together a multi-modal search system. Very good. So I hope this was helpful, and I hope you now have more information, or at least some knowledge, when it comes to multimodal RAG systems. And so if you want to learn more about multimodal RAG systems and how to build multimodal RAG system or multimodal recommender systems, I have a course that I put together, and you can find it somewhere in the description. And so you can go deeper into this whole realm of multimodal RAG systems. I hope this was valuable, was useful. And if you are new in this channel, go ahead and subscribe, because that would make me happy. And I would know that at least I'm doing something that is valuable. And also, I love to hear from you. Don't forget to leave a comment let's say something nice. You can say RAG systems, you can say Poly great, you can say more content like this, whatever it is, at least so I can have some sort of feedback from you. Again, thank you so much for your time. Till next time, be well.